Yeah, for those of you who already watched my long version of how to solve this question, which is question 2 on homework 4, or for those of you that don't need to watch the long version, perhaps you already understand the basic ideas about how to solve this kind of problem. Here's a short version of how to do it, how to solve it. Now, let's read the problem first. A candy distributor needs to mix a 30% fat content chocolate with a 50% fat content chocolate to create 150 kilograms of a 35.3% fat content chocolate. How many kilograms of each kind of chocolate must they use? Write an equation that uses the information as it is given above that can be used to solve this problem. Use x as your variable to represent the quantity of 30% fat content chocolate. So let's do exactly that. We're going to use x as the number of kilograms of 30% fat content chocolate. And we know that the total amount of chocolate, after you combine the two together, we want to end up with a big container. In other words, we can combine a container of 30% plus a container of 50%, and we're going to end up with 150 kilograms. That means if X is the number of kilograms of 30% fat content chocolate, then 150 minus X is the number of kilograms of the other kind, the 50% fat content. You put them both together, you got 150 kilograms. Now, before I go on with this any further, let me remind you, 30%, when we represent as a decimal, becomes 0.30 or 0.3. 50% expressed as a decimal becomes 0.50 or 0.5. This 35.3% that we have here, expressed as a decimal, becomes 0.353. I just want to make sure everyone remembers that when you see it in my equation that I'm about to write. Now, we know that our goal is to end up with a mixture. I'll put this over here. The mixture is going to the mixture is going to contain 35.3% chocolate, which I just mentioned to you. I forgot to put the percent sign here. As a decimal is 0.353. So if we multiply 0.353 times 150, because that's the number of kilograms that we're going to produce by combining the two kinds of chocolate. And this is the amount of fat that's in the combined mixture. It contains 0.353 times 150 kilograms of fat. But we put that together by the following way. We had the 30% fat content chocolate, which we added to the 50% fat content. And remember, we have X kilograms of the 30%, 150 minus X kilograms of the 50%. And now we really have our equation. I mean, this is the equation that I'm going to submit to my open math, and they liked it. They gave it a green check. Now, So first, when we solve it, let's do this. 0.30x plus 0.50 times 150. I can do that in my head. That's like 1/2 of 150, which is 75. And then we take this times a negative x, we get a negative 0.50 or a negative 0.5. I could have called it, but a negative 0.50x equals, and then I've done this calculation already. This multiplication was that. I'll put these next to each. Ooh, I'm getting kind of low on the page. Sometimes I forget to move the page. 0.30x minus 0.50x. Put those next to each other because they're like terms. Equals 52.95. So of course this subtraction here gives us a negative 0.2x. And let's subtract 75 from both sides to get a negative 22.05. Now I'll divide both sides of the equation by a negative 0.2. We get x, which is going to be, you see, a number of kilograms of the 30% chocolate is 110.25 kilograms. And 150 minus x, which is the number of kilograms of the 50% chocolate, then is 39.75 kilograms. And those are the two answers that we submitted for the numbers of kilograms of the two kinds of chocolate.